طيب يا شباب يعطيكم العافية. We finished effective stress concept and moved to stresses due to surcharge. Stresses due to surcharge. As we explained in the previous lecture, if we have, for example, a building, then when we try to find the stress at point A, which will be, or stress at point A, this is point A. So it will be two types of stresses. One is due to this weight of soil above that point, weight of soil. This is, we call it stress due to soil, sigma due to soil, the soil weight. But also we have stress due to the weight of the building. So we call it sigma due to the building. So total stress equals to stress due to soil plus stress due to building. Now, stress due to soil, we already studied it. That's what we finished until now. Okay? We know how to find stress. We know how to find total effective pore water pressure, right? At any point, right? And we know if there is water, how to deal with it. If there is a zone of capillary rise, how to deal with it. Okay? We are experts in dealing with stress due to soil. Now we need to know how to find stress due to building. Stress due to building. Or what we call it, stresses due to surcharge or buildings. Surcharge is anything, any load above the soil. Okay? Stresses due to surcharge. Because total stress, as we said, total stress is stress due to soil plus stress due to building. Sigma S, stress due to soil weight. Sigma B, stress due to surcharge, weight of the buildings. Okay? We have to do a review, but before that, let us go back to speak about these stresses. Okay? Stress due to building. Yes, we said that we have to do, let us do this. Okay? Stress due to building, we said last time, it's a function of, right? There are several factors that affect the stresses due to the building. What are these factors? Load. Okay, if I have, for example, if I have 10-story building, it's not like one-story building. It's not like a dam. It's not like a bridge. It's not like a tower. It's not like whatever. Okay? So P is one factor. Good. What is the other factor? Soil. Soil, it means soil type, soil structure, soil formation, water content in the soil, degree of saturation in the soil, void ratio, porosity, all what we studied until now about soil. Whether it was sand, it was clay, it was saturated, it was dry, there is effective stress, or all of these things. Okay, so it's all information about the soil. Okay, that's good. What else? Contact surface. We said there is a difference between a camel and a horse while walking in the desert, right? So there is a difference between concentrated load, distributed load, and how this load is applied to the earth, okay? So this is one factor. That's good. What else? Depth. Okay. So for example, due to me, stresses at depth of half meter is not like the stress at depth of 10 meters, right? Okay. As we go deeper, the stress will increase or decrease? Decrease. As we go deeper, the stress will decrease. At the same time, as we go away, okay, for example, stress is due to me here, it's not like the stress is due to me there, right? So as we go also in the horizontal direction, away, so this is, instead of depth, we say distance. Distance. It means horizontal distance. Okay, what else? Many other factors. Modulus of elasticity, Poisson's ratio, OCR, K naught. This is not coefficient of permeability. So there are several factors affecting sigma B. So when I have to calculate sigma B, I have to consider all these factors. But you see, it's difficult to have all these factors because all these factors will give us, every factor at least will give us one variable, right? So I will have an equation with many variables. So I cannot solve it. It will be indeterminate problem. You know what is indeterminate? You know what is indeterminate? Unknowns are much more here, much more than equation. That's half of the problem. You know what is the other half? I don't know how many are the unknowns. I calculated them. I thought that I have 11 unknowns. After finishing everything, I found additional 20. I forget to count them. So, see, I cannot even predict how many unknowns I have. So, it's a problem. What I have to do? Try to eliminate many of these factors, right? I cannot eliminate them by just ignoring them, but if I can deal with equation in a way that I may do some of these variables as constant, okay, put them as numbers. Remember the equation when we had K equals 2.303, etc., etc.? Remember that? Remember? Variable, falling head permeability test, well pumping permeability test. Remember that, okay? From where we got at that time 2.303, remember, I told you. It's the result of many constants and etc. variables, etc., etc. Okay? So, what we have to do? Let us try to take this away, because, by the way, this is soil, 4 letters, right? But it contains structure, texture, type, situation, condition. It has many variables, okay? I will try to eliminate it, or to make it constant, or to make it, I will take it into consideration, but I will try to free you from having it as into consideration, okay? So, what I have to do, depth and spacing, I will try to make it one factor, and then P, I will try to put it in the equation, whatever you have P, you put P, and then that's it. And then I will try to fix contact surface. How to fix it? Okay, if I take it like this, for this contact surface, I have an equation that has P and depth and distance. Okay? For this type of contact surface, I will have so and so. For this type, so what I have here is, I have several contact surfaces, because contact surface can be just few. In practice, I have either concentrated load or distributed load on a square or a circle or a rectangle, right? So you will see that I have just a few, not more than 6-7 types of contact surfaces. So if I put this for contact surface number 1, I have a function of P, depth, distance, of course, taking into consideration soil. For this type, for that type, etc. So I will end up with 6-7 equations. That's easier than having 100. Okay? This is one thing. So, 2 persons try to solve this problem, having the same methodology, the same practice, the same idea. So what is the difference between them? It's not in P, because P, you have to put it. It's not in depth and distance, because you have to put it. It's not in the contact surface, because they are fixed. So what is the difference? In soil. They considered, let us have W water content, equals to in medium 0.25. That one said, no, let us take it in medium, it's 0.3, okay? So these are the only difference between them, between these two, is their names. They have different names. And their idea about the soil. But you will have the same equation, the same equations, okay? So, who are they? Boussinesq. Boussinesq, one. French, right, from his name. Boussinesq, French. Westergaard. Whatever. Boussinesq and Westergaard. We have two people, two persons, okay? Boussinesq and Westergaard. They suggested solutions for our problem. They suggested solutions. But they have the same solution, the same equation. The only difference between them that one begins with B, the other begins with W. That's right. One is French, the other is American. That's true. And one has the constants different than the other. Okay? Both of them, their solution is in your textbook. Okay? So, for every case you have solution due to Boussinesq, due to Westergaard, due to Boussinesq, due to Westergaard, except one condition. Okay? For us, what is needed is Boussinesq. France is closer than the United States. Right? I don't speak about hearts. I speak about distances. I speak about distances, about geography. Okay? So we will deal with Boussinesq, not with Westergaard. But you have the both solution there. By the way, I may give you a question, and I may ask you to please solve this problem according to Boussinesq. Then you solve it according to Boussinesq. Please solve this problem according to Westergaard. Then you have to solve it according to Westergaard. Both solutions are there. But if I said please, or without please even, solve this problem, and without saying Boussinesq or Westergaard, so we will use Boussinesq. Okay? Okay? Use Boussinesq always, unless I told you to solve it according to Westergaard. Okay? Both solutions are there. Now, before going to Boussinesq or Westergaard, let us go to make some review. I know that you love very much strength of materials, especially at spring, okay, or at summer. Depends when you took strength of materials. Summer. نعمل review بسيطة. Okay? We will make a review. Although you must be experts and familiar with stresses and strains and principles of statics and strength of materials. You are familiar with it, right? You know it very well. You know how to draw more circle and how to use it, right? No. This body, and we have forces on it, right? Forces on it. You remember that we took it, let us call it A, B, C, D. We have this element. This element, if it is under equilibrium, then it has forces, right? These forces, they may be in, like here we call them, let us call this sigma y because it's in the y direction. This is sigma y, and this is sigma x, and this is sigma x. These are the forces acting on this plane, right? Two forces in the y direction, they cancel each other. They are the same value, opposite in direction, so they cancel each other. Sigma y, sigma y. Summation of sigma y is 0. Summation of sigma x is 0. Otherwise, it's not equilibrium. You know what is equilibrium, right? Otherwise, Otherwise, it's not equilibrium. And also, in most cases, we have shear also. Remember? Shear. This is the shear. We call it tau xy. Tau xy. Remember that, right? Okay, if I have this, for example. This is under equilibrium. This is not under equilibrium. Why? Because there is a rotation. The shear is moving the same direction. But here the shear, this one goes this way, this one goes this way. الرأس للرأس والذنب للذنب. تعرفوا القاعدة. Heads to heads, tails to tails, right? So this shear will move the body this way. This shear will move it the other way. They are equal. So this one will make rotation this way. This one will make rotation the opposite. So they will cancel each other. This two. So this is always the same case. Otherwise, you will draw it wrong. Okay. Otherwise, it's not equilibrium. You are familiar with this. Okay. Sigma y equals to sigma y. Sigma x equals to sigma x. Tau xy. Tau xy. Okay. These make rotation in this way. This make rotation in the opposite way. Okay. By the way, before we begin, let us agree on one point. Okay. Directions. You took this. The compression is positive or negative? Negative. You took it negative, right? Remember, on the strength of materials in concrete, if you took concrete. Compression is negative. Tension is positive. Remember that? Compression is negative. Okay? Is it like this? You don't remember. Compression, okay, and tension. Compression is negative, and tension is positive. In our case, in soil, we will put this, okay. We will put this in a frame later. But remember, in our case, this is positive. Compression is positive. Compression is positive. Okay, compression is positive. Let us move to the other point. Okay. So we have this element. If we took this element and let us try to this is sigma y, right? Sigma y, sigma x, and this is tau xy, and of course we call this is A, B, C, D, right? If we took an inclined plane, EF is an inclined plane. It is inclined at angle theta. This is angle theta, okay? So we have inclined plane, EF at angle theta from AB, okay? What I want is, what are the stresses affecting on the inclined plane, okay? What we do usually, we do, if you remember this free body diagram, remember? We take free body diagram. Free body diagram means the diagram that represents what I am interested in, okay? So here, we have it. Let us name it. This is point E, right? This is point F, right? And this is B, okay? Now, we have sigma y, tau xy, right? Sigma x, tau xy, right? And we have, this is theta, okay? Now, when we made this inclination, always we have two forces. One is perpendicular at the surface. The other one is tangent. Remember? Tangent. We have perpendicular and tangent, right? The perpendicular, we call it normal stress, and the tangent, we call it shear stress, right? So we will have here sigma, I will call it normal, so sigma n because it's normal. And it is in the direction, I will call this direction N. Okay? N is not north. n is normal, in the normal direction, okay? And I will have tau, no, not tau, sigma tau s. Let us call it tau s. Or tau, okay. Shear stress. It's in the direction, I will call it S. Okay? Okay? Shear stress. So I will have here sigma n and tau. Let us call it tau n also. I will call it like this. Sigma n tau n. Okay? So what I want to do here is to find sigma n and tau n. That's my problem. To find if I have a free body diagram, if I have an element where I have sigma x and sigma y acting on it, and tau xy as shown and as drawn here, okay, and if I have an inclination with angle theta, okay, how much is sigma n and tau n? I mean, how much is the normal stress and the shear stress on that plane? Normal stress is always perpendicular and shear stress is always tangent. Okay? Now, here we will go to some mathematics. Okay? For example, I will try to make the unknowns as less as I can. Okay? For example, let me write it on this. EB. The line EB. EP. Okay? Can I write it equals to EF what? Cosine theta? Can I write it like this? Look, EF cosine theta means EB over EF. So I end up with EB, right? Can I write FB equals to EF sine theta? Yes, because EF sine theta means FB over EF. So I end up with FB, okay? So I wrote those two equations. They are important. EB, here, EB equals EF cosine theta. EB equals to EF sine theta. Right? Let us go back. هاي اف بي مظبوط مش اي بي اف بي بتنمسحش اف بي بدها تعليق اف بي بتساوي اي اف ساين ثيتا. اوكي طيب نرجع مرة ثانية. الآن علشان نحل هاي المشكلة how to solve it, let us say that we will take all forces at the direction n. Summation of forces at direction n should be 0. Summation of forces. So what forces we have? We have sigma n acting at angle 90, right? Right? So sigma n, of course it will be intensity on EF. It will be on EF, right? This is one thing. We have also sigma y on the opposite direction, right? Sigma 1, but I have to change it from here to here, right? And then I have sigma x, but also I have to change it from here to here, right? And I have tau xy, right? But I have to change it to this direction. And I have tau xy, but I have to change it to this direction. But you see, all forces, sigma x, sigma y, tau xy, they are moving up, while sigma n down. Summation of them equals to 0. Then sigma n should equal to all of them, right? Right? Okay. So summation of forces on the n direction equals to 0. Let us try to write it. The drawing is in front of you. Okay, I will try to use the same drawing because I want you to see how I get it. Let us see. Sigma n, right? It should be multiplied by EF, right? Because it's intensity on all the cross section, the section that it will be applied to it. Sigma n multiplied by this. Minus, 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 minus equals to 0, right? So I can say equals at the beginning, from the beginning. It should equal everything else. Let us take sigma x. Sigma x, it affects on what plane, what line? FB, right? FB. But FB, here it is. I can write it EF, right? EF sine theta, right? So instead of writing FB, I wrote EF sine theta. But this will give us this way. To move to this way, I have to multiply it by sine theta again. So it will be sine square theta. You can try this at home. Okay? Plus sigma y. Sigma y multiplied by EB. But EB is cosine theta. And to move to this direction, it has to be multiplied by cosine theta. So it's cosine squared theta. Okay? Plus. You see, this will move to this way, and this will move to this way. They are in the same direction, but they have. So I can write plus 2 tau xy. Okay. EB, which is EF sine theta, EF cosine theta. So it will be EF sine theta cosine theta. Okay? Sigma n equals to all of these things. Sigma n multiplied by EF equals to sigma x, EF sine theta, so sine square theta, plus sigma y, EF cosine theta multiplied by cosine theta, so cosine square, plus 2 tau xy, EF sine theta cosine theta. You can try it at home to check if it is right or wrong. And it is, by the way, explained well in your textbook. Page, you have the textbook with you? I have it. 105. Page 105. 105. So you can check it there and continue. So are you following with me? 2 tau xy. Did I write? Yes, 2 tau xy, sine theta, cosine theta. Right? Okay. Now, you see that we can, for example, we can omit EF from all places, right? We can take them away. So we ended with sigma n equals to sigma x sine square theta plus sigma y cosine square theta plus 2 sine cosine theta. Okay? Or we can end up with, let us have it here written. Okay? The final one, which is sigma n equals sigma y plus sigma x divided by 2 plus sigma y minus sigma x divided by 2 cosine 2 theta plus tau xy sine 2 theta. This is the result. Okay? This is the result. Sigma n equals sigma y plus sigma x باي 2 plus sigma y minus sigma x by 2 cosine 2 theta plus tau xy sine 2 theta. This is the result. لا حفظ وفهم. شو ضل تقول لي نسيت اسمي. ما هذا اخذتوها في استاتيك، اخذتوها في strength of materials، وهون سهله. على كل مش حتحفظها، حتشوف لسه ما خلصناش. اوكي سيجما ان equals sigma y plus sigma x by 2. لاحظوا انه هون انا هي ضوالي، فانا راح احكي بالعربي هالكلمتين وبعدين بنكملهم الحصه الجاي. لاحظوا انه هون كل ما فيش شيء مجهول. سيجما واي بعرفه، سيجما اكس بعرفه، تاو اكس واي بعرفه، ثيتا بعرفها. صح؟